Hey guys, welcome back for another SVSU Math and Physics Resource Center tutoring video. My name is Brendon. I'm going to be your tutor for this video, and we're going to get into the basics of using power series to represent functions. All right, hope you guys enjoy. All right, so to begin writing functions as power series, what we're going to do is we're going to begin with the geometric series. So I have the geometric series form written out here. It's this infinite series as n goes from 0 to infinity of a times r to the n. And we know that this converges, this series converges when the absolute value of r is less than 1. And we know it converges to a over 1 minus r. Okay, so now what we're going to do is we're going to say, well, what if we specify that a is equal to 1 and r is equal to x. Let's see what this looks like. So this is going to be the summation as n equals 0 to infinity of a, which is just 1, so we're not going to write that. And then this is going to be x to the n. We know that this series here, this power series, would converge to 1 over 1 minus x when the absolute value of x is less than 1. So basically what we're saying is if I have the function of x of 1 over 1 minus x, this is equal to the power series as n goes from 0 to infinity of x to the n. But it's only true when x is less than, or the absolute value of x is less than 1. And the reason is because if our absolute value of x is not less than 1, then our power series diverges and we don't get it to converge to this function. Okay, so we're gonna use this here, this base function of 1 over 1 minus x, to write maybe a little bit of a more complex function into a power series. So let's go ahead and take a look at what that would look like. So we're going to start with this example here. We have the function of x of x cubed over 3 minus x squared. So what we want to do is we want to get it into the form of something. So f of x. Actually, let's go g of x of 1 over 1 minus x, right? Because this was our geometric series that we know we can write as a power series. So if we can get it to look similar to that, and then we can insert our power series. So the first thing I'm going to do to this function is I'm going to pull out the x cubed. So we're going to pull out the x cubed, and then we're going to be left with a 1 over 3 minus x squared. Okay, so now that we have that, we're close. Except we have this 3 here. So it's fine if we have this x squared term here, because we could just make that our x term. And but this 3, we need this to be a 1. So what I'm going to do is I'm going to factor out a 3 from the denominator. So this is going to be x cubed times 1 over 3. So when I factor out the 3, I get a 1 here, but then minus. I'm going to have to divide by 3, so I'll have x squared divided by 3. And so if you were to distribute, you want to double check that if you were to distribute this 3 back through the denominator, you would get what you ended up with. So 3 times 1 is 3, and then 3 times x squared divided by 3 is going to be x squared. So that ends up getting us back to where we were. So then now this is just being multiplied, so we can pull this out with the x cubed. So it's going to be x cubed divided by 3 multiplied by 1 over 1 minus, and I'm going to put a parenthesis around this, x squared divided by 3. Right, so this is exactly what our g of x is here, right? So except our x in this term is just going to be this x squared divided by 3. So for our interval of convergence, what we'll do after we represent this function as a power series, we're going to use this. So r is equal to x squared divided by 3. Okay, so now let's go ahead and continue with this. So this is going to be x cubed divided by 3, and then so now we can write this as a power series. the summation as n equals 0 to infinity of x to the n, right? Except in this case, our x is going to be x squared divided by 3 to the n. Okay, and so now what we want to do is we want to simplify this because we want to get these terms back inside of the power series. So this is going to be, I'm just going to simplify the inside of the power series for this step. So this is going to be x cubed divided by 3, summation as n equals 0 to infinity. What I'm going to do is I'm going to break up these two terms. So I'm going to have a 1 over 3 to the n times x squared to the n. Okay, so now we should be able to put these two terms into the power series pretty easily. So this is going to be the summation as n equals 0 to infinity. So if I want to put this into here, we can break this up into a 1 over 3 times 1 over 3 to the n. And then I can break up the x cubed, so I can have x cubed times x to the, and I can write this as 2n. So now let's see what it's going to simplify down to. We have the summation as n is equal to 0 to infinity of 1 over 3, and using our exponent rules, we can make this to the n plus 1, multiplied by x to the 2n plus 3. So this is our power series representation of our initial function that we had. This f of x is equal to x cubed over 3 minus x squared. But now we want to find the interval for which this holds true, right? So this interval is just going to be our interval of convergence, and we know that this is when r is less, or r is equal to x squared divided by 3. The absolute value of r is less than 1. Okay, so now what we can do is we can pull out this 1/3 out of the absolute value, so 1/3 absolute value, and then we can also pull out the squared absolute value, and then squares on the outside is less than 1. So then I'm going to multiply both sides by 3, so the absolute value of x is less than 3 squared, and then we're going to take the square root of both sides. So we'll have the absolute value of x is less than square root of 3, and then breaking up our inequality, breaking up the absolute value in our inequality, we're going to add the other side, so it's going to be negative square root 3 is less than x is less than square root 3. So this is going to be our interval of convergence. So then that tells us that this power series represents this function only when x is between negative square root 3 and positive square root 3. Okay, so that's it for this video. For the next videos, what we're going to do is we're going to start doing some calculus. So we're going to do some integration with power series, and we're going to do some differentiation with power series.